Welcome students, welcome to the chapter Haloalkanes and Haloarenes. This is the chapter for class 12. We will start with an introduction. This is part 1 of the chapter, and so we will start with an introduction into this chapter. Haloalkanes and haloarenes are hydrocarbon derivatives. What does this mean? So first what we want to know is what is an hydrocarbon and what is an alkane and what is an arene. So alkanes are nothing but aliphatic hydrocarbons. So hydrocarbons are the organic compounds that contains only carbon and hydrogen. So hydrocarbon means organic compounds that contains only carbon and hydrogen. And alkanes means hydrocarbons that are straight chain. So straight chain hydrocarbons are called alkanes. So I will write down the first member of that family here, and that is nothing other than methane. So we have methane, one carbon and 4 hydrogen atoms. So haloalkane means, so you are bringing a halogen atom into it. Halogen atom means either fluorine or chlorine or bromine or iodine. If you are bringing that atom into it, then you call it as haloalkanes. So I will write the structure of bringing a halogen into it. So this, if I am removing one hydrogen atom from methane, I removed one hydrogen atom, so it is CH3, and instead of that hydrogen atom I am introducing a halogen group. So this X, it can be any halogen, that can be chlorine, fluorine, bromine or iodine. So it can be fluorine, chlorine, bromine, iodine, any halogen, then it is called a haloalkane. Now what is haloarenes? So what are arenes? Arenes are aromatic hydrocarbons. Aromatic. So first I will draw the first member or the most famous member of aromatic compounds, that is nothing but, so I have benzene as the first member. So first member is benzene. In the benzene I have alternate single bond and double bond. So if I have alternate single and double bond, and if it is in rings, if it is having a ring structure, I can call it as an aromatic, or in general terms we call it as arenes. So in arenes, every carbon has an hydrogen. Every carbon has an hydrogen. So if I write the formula of the compound, I can write it like this. So it is C6H6. So this is benzene, the same compound that is written here. It can be written as C6H6. So if I am substituting or removing one hydrogen and placing one halogen with it, so let's see what happens. So I am removing one hydrogen and I am placing, so I have removed, so the compound becomes H5. Now I am placing a halogen, then now it is nothing but haloarenes. So we have seen haloalkanes and what are haloarenes. So let us see. So here, this is what I have written just now. Methane, one hydrogen is replaced by Cl, then it is haloalkane. Similarly, ethane, one hydrogen is replaced, from here one hydrogen is removed and I placed Cl, then it is haloalkane. Clear? So in the case of haloarenes, I have removed one hydrogen of benzene and I will get haloarenes. So aliphatic hydrocarbon, if I generalize this, aliphatic hydrocarbon, which is usually represented as RH. So RH is an aliphatic hydrocarbon. It can be methane, ethane or any straight chain hydrocarbon. From this aliphatic hydrocarbon, one H is removed. Then you will get the alkyl group. R is the alkyl group. Along with that, you will put one halo atom into it. So this is called haloalkanes. So aliphatic hydrocarbon is now, or the haloalkanes is now derived from aliphatic. So it's called hydrocarbon derivative. On the other hand, aromatic hydrocarbon, which can be represented as A or H. Here the H is replaced by an halogen atom. Then you call it as haloarenes. Clear. So we have haloalkanes, and now we know how the compound has been derived, and we have haloarenes, benzene and its halo derivative. Clear. So X can be fluorine, chlorine, bromine, or iodine. It can be any of these halogen atoms. Now here is the haloalkanes that we just saw, also haloarenes. So while naming these compounds, there are two methods that has been adopted. Either you can use IUPAC naming, or you can use the trivial naming. IUPAC naming or trivial naming. So in both cases, now what is the difference between the IUPAC naming and trivial naming? So in the IUPAC naming, you can see from the name, halogen atom is named first, which is followed by the alkane. Halogen is named first, which is followed by alkane. Whereas in the trivial naming, the alkyl group is named first, then the halide. So let us look with an example. Here I have ethane, in which one hydrogen atom is replaced with chlorine. So if you are looking into its IUPAC name, I have first its functional group, that is chloro, then I have the alkyl group, that is ethane, chloroethane. So in organic chemistry, whenever or the name with which a compound ends is called the parent of that compound. So here in this case, in the IUPAC naming, ethane is treated as its parent of in this compound, the alkyl group. So alkane is treated, or R group is treated as the parent. Clear? Whereas Cl is treated as a branch, or you can say it is just a functional group branch. Whereas in the case of trivial naming, halide is used as a branch or a parent, and alkyl group is treated as a branch. So you can see it from here, ethyl chloride. The name ending with this chloride suggests that it is treated as the parent, whereas ethyl is a branch. So that's the difference in IUPAC and trivial naming. When IUPAC uses the parent hydrocarbon and chlorine as branch, it's the other way around in the trivial or in the old naming. Same is the case with haloarenes. You can see halo is initial group, then the parent is arene. Whereas in the case of trivial naming, aryl is the branch and halide is the parent. So we will look into the example of benzene with chlorine. So as I said, in IUPAC, chlorine is treated as a branch, whereas benzene is the parent. Whereas in trivial, whenever benzene is coming as a branch, we call it by the name phenyl. So whenever benzene is a branch, we call it as phenyl, and chloride is the parent here. So it is named as phenyl chloride. So in the trivial naming, so that's the basic difference. In most of the compounds, we have to learn the trivial namings. In many compounds, we have to learn trivial naming. IUPAC is simple because once you know the law that decides in the nomenclature of IUPAC, it is easy to follow. It is easy to name any compounds. Whereas in the case of trivial naming, there is no universal laws governing it. So it's a bit difficult, but sometimes it is essential to learn them, because those trivial names might be more known than the IUPAC name. So once the trivial name is very famous, then uh, IUPAC even accepts such names. For example, benzene. Benzene is the trivial name of this compound, but IUPAC has accepted that name because of its popularity. Clear. So this is a general overview of naming and the specific nomenclature and all the rules governing the nomenclature we will see in detail in the coming parts. Okay. So before concluding this part, let us make a quick look into the importance of the organic compounds containing halogen. So why is these organic compounds containing halogen like haloalkanes and haloarenes so important? The first and foremost thing is that in many of the natural occurring compounds, we have this organic compounds containing halogens, which shows it has some significance in supporting life. Clear. Then its wide application in industry and also in our day-to-day life, many things that we use contains organic compounds having halogen in it. Clear. Now this is one class of compounds that serves as solvents for relatively non-polar compound. What is non-polar? Non-polar means the compounds that are not soluble in water. Mainly those compounds that are not soluble in water are soluble in certain organic compounds that contain halogens. For example, chloroform, carbon tetrachloride. These are all organic compounds containing halogen. Chloroform having formula, so I will write it here. The formula is CHCl3, chloroform. So you can see here we have halogen inside this hydrocarbon. 3 chlorines are substituting the methane family. Clear. So one is chloroform, the other one is carbon tetrachloride. So we can write it like this, CCl4, another compound. So all these compounds that I have written here can serve as solvents for non-polar compounds. Clear. Next, it serves as a starting material for the synthesis of many organic compounds. So it's a starting material, which means that it is a turning point in the synthesis of many organic compounds that has lot of important applications. So you can say, in other words, it serves as a mother for many organic compounds. Then chloramphenicol, that is an antibiotic that extracted from microorganism. This chloramphenicol is again another organic compound containing halogen. This has found to be very effective in the treatment of typhoid fever. For treating typhoid fever, this antibiotic has shown a significant amount of influence. So it's a useful thing in the medical field. Again, from the medical field, one of the glands or one of the hormones in human body is thyroxine, a gland producing hormone in which it has iodine. So if someone is deficient in iodine, automatically they will be deficient in thyroxine, and this will result in a disease called goiter. So this gland is seen just below the neck, on the just below this Adam's apple, and once if a patient has a goiter symptom, then it starts to swell. Clear. So it forms a bump around the neck. So this is the symptom of goiter, and that is due to the deficiency in iodine containing organic compound, which is a hormone named as thyroxine. And another one, chloroquine, hydroxychloroquine, is one of the famous drug that came to limelight when in the earlier periods of COVID. There were suggestions from various medical practitioners that chloroquine can impart immunity against COVID, but later those were being rejected and has found only little significance for the treatment of COVID. However, chloroquine, a synthetic halogen compound, became famous for its effectiveness against malarial fever. So a mosquito causing spreading fever, that is malaria, and chloroquine, hydroxychloroquine, was found to be very effective. Clear. So again, it came into limelight during the early phase of COVID, and India was one of the among uh, or, or, or the world's top producer of chloroquine. Next is halothane. It's a class of organic compound that is used as an anesthetic during surgery. Halothane, it was used as an anesthetic during surgery. In earlier days, this compound CHCl3, before the invention of such halothane and other anesthetics, it was CHCl3 chloroform that was used during surgery in order to make patient unconscious. But the risk level of using chloroform is too high, so that later they have stopped using this with the invention of new anesthetic drugs. That class is called halothane, so it is used as an anesthetic during surgery. So this is all about the introduction into the haloalkanes and haloarenes. Thank you.